In this video, we will discuss solving higher degree equations by factoring. A quadratic equation is an equation that has at least one variable term raised to the second power and no variable terms with power greater than 2. Quadratic equations are also called second degree equations. We can define other polynomial equations similarly. A cubic equation has at least one variable term raised to the third power and no variable term with a power greater than 3. They are also called third degree equations. The degree of an equation in one variable is the highest power of any variable term that appears in the equation. The degree of a polynomial equation is also the maximum number of solutions the equation may have. Linear or first degree equations have at most one solution. Quadratic or second degree equations have at most 2. Cubic or third degree equations have at most 3. And fourth degree equations have at most 4. State the type of equation according to the degree of each of the equations. X squared plus 3x plus 4 equals 0 is a quadratic or second degree equation. X cubed equals 27 is a cubic or third degree equation. X to the fourth plus 3x cubed plus 2x squared plus x plus 4 equals 0 is a fourth degree equation. X to the eighth equals 256 is an eighth degree equation. And 3x plus 7 equals 5x minus 3 is a linear or first degree equation. Higher degree equations that can be written in factored form can be solved using the zero product property. If the product of the factors is equal to 0, then any factor containing a variable may be equal to 0. To solve a higher degree equation by factoring, first write the equation in standard form, then factor the polynomial side of the equation, set each factor containing a variable equal to 0, solve each equation from step 3. Solve the equations for the exact roots using the zero product property. A, x times x plus 4 times x minus 3 equals 0. There are 3 factors. We set each equal to 0 and solve. If x equals 0, we are done. If x plus 4 equals 0, then x equals negative 4. If x minus 3 equals 0, then x equals 3. The solutions are negative 4, 0, and 3. B, x plus 5 times x minus 7 times 2x minus 1 equals 0. There are 3 factors. We set each equal to 0 and solve. If x plus 5 equals 0, then x equals negative 5. If x minus 7 equals 0, then x equals 7. If 2x minus 1 equals 0, 2x equals 1, so x equals 1/2. The solutions are negative 5, 1/2, and 7. C, 2x cubed minus 14x squared plus 20x equals 0. First, we must factor this. We can easily factor out 2x from each term to get to 2x times x squared minus 7x plus 10 equals 0. And x squared minus 7x plus 10 equals x minus 2 times x minus 5. So 2x cubed minus 14x squared plus 20x equals 2x times x minus 2 times x minus 5. If x equals 0, we are done. If x minus 2 equals 0, then x equals 2. If x minus 5 equals 0, then x equals 5. The solutions are 0, 2, and 5. D, 3x cubed minus 15x equals 0. First, we factor. 3x cubed minus 15x equals 3x times x squared minus 5. If x equals 0, we are done. If x squared minus 5 equals 0, then x squared equals 5, so x is plus or minus the square root of 5. The solutions are negative square root of 5, 0, and square root of 5. Any equation can be graphed by writing it as a function and using the table of solutions method. It is important to include enough points to get a complete view of the graph. Prepare a table of solutions and graph the function f of x equals x cubed using integer values between negative 2 and 2 inclusive. Determine the domain and range. We use the values of x, negative 2, negative 1, 0, 1, and 2, which correspond respectively to negative 8, negative 1, 0, 1, and 8. The graph of the function appears on the next slide. Here is the graph of the function. We see all of the points as these colored dots on the graph. The domain of any polynomial is the set of all real numbers, and x cubed is a polynomial. The range of any polynomial with an odd degree is also all real numbers. So both the domain and range of x cubed are the set of all real numbers. Equations in two variables describe a relation between the variables. This connection between the variables defines a set of ordered pairs. The equations in two variables that we have examined thus far have been functions. A function is a relation that has exactly one value of the dependent variable for every value of the independent variable. All functions are relations, but not all relations are functions. A relation that is not a function will have at least one case where a value of the independent variable corresponds to more than one value of the dependent variable. To distinguish between a function and a relation using the vertical line test, first, graph the relation on a coordinate system. Second, apply the vertical line test. Then, if a vertical line can be drawn so that it intersects the graph at more than one point, then the graph is the graph of a relation that is not a function. If no vertical line can be drawn so that it intersects the graph at more than one point, then the graph is the graph of a function. Determine which graphs in the figure are graphs of functions. The graphs in A and C are the graphs of functions. However, the graph in B is not the graph of a function because there are many vertical lines that can be drawn that would intersect the graph at more than one point. In fact, the line x equals A, where A is greater than 0, will always intersect the graph at more than one point. The domain of a relation is the set of all values that are appropriate for the independent variable. The range is the set of all resulting values of the dependent variable that correspond to the independent variable. To find the domain and range of a relation from a graph, first graph the relation on a coordinate system. The domain is the set of all values on the graph for the independent variables, the x values, and the range is the set of all the values on the graph for the dependent variable, the y values. Determine the domain and range of each relation. For A, the domain is the set of real numbers. The range is the set of real numbers greater than or equal to 0. For B, the domain is the set of numbers from -3 to 3 inclusive. The range is the set of real numbers from -2 to 2 inclusive. For C, the domain is the set of real numbers from -3 to 5 inclusive. The range is the set of real numbers from -4 to 6 inclusive.